Hello and welcome to today's webinar, Achieving Fail-Safe Software Deployments at the Edge. My name is Jordan and I'm in marketing here at Progress. Now I'm going to introduce you to today's presenters, Adi and Chaitra.
Thank you, Jordan. Hey, everyone. I'm Adi Shankar, and I'm the product marketing specialist for Chef Edge Management. With me today is Chaitra, who leads the product management for this product, as well as Fani Sajja from our engineering team, who will be answering your questions at the end of the webinar. And over the course of next hour today, we'll go through an overview of DevOps at Edge and how you can take charge of software deployments to your devices that are distributed across various geographical locations. We'll see how this paradigm can be orchestrated with Chef and the benefits that you can derive from it. So with that, let's get started. Now, you see, I want you to imagine that you were the CIO of an organization and an update that your team pushed to every retail outlet in a region resulted in a very long downtime. Or imagine dealing with a problem where you are basically taking customer orders manually and you are having no help from the IT team. Or maybe think about a situation where you are a CIO and you dedicate a large percentage of your staff to simply managing and deploying and even troubleshooting configuration problems. Or think about a situation where you are basically in an you are in a situation where you are trying to avoid misconfiguration problems, but while doing so you have basically allowed a cyber attack to expose credit card or personal information, and in the end, you were basically asked to address all of these fallouts, which was around lost revenue, legal costs, and on top of everything, the reputational harm. Imagine if you pushed an application change to a distributed set of locations and you had no visibility on whether they worked or not until your desk was flooded with calls. So you see all of these situations, it could typically be resolved by implementing DevOps methodology at the edge. But before we deep dive into any of it, I would like you to know about what edge devices are all about. So edge devices are the type of devices that perform an important task of connecting and exchanging of data with the corporate network, obviously via internet. And these devices are basically distributed in non-data center locations across the globe with constantly changing connectivity and environmental conditions. And these devices could be as close to where the data is generally, generated and consumed. Now, we all know that DevOps method of managing devices in your infrastructure is considered to be one of the best ways. And the reason why I say this is because it helps you in building topologies that are flexible with repeatable data flow pipelines using a code-based approach. It also helps you in executing run pipelines on the system at the data center and auto-scaling on-premise clusters or cloud environments. It also helps you in managing and operating data flow performance through continuous monitoring and enforcement. And obviously, DevOps, it treats application security as an overarching concern, which is considered at every point in the deployment process. But you see, these perimeter and challenges, it gets amplified when DevOps principles are applied on your edge devices. And what are those challenges? Well, there are many challenges, but I have highlighted top four of them. And it's around deployment and rollbacks, maybe due to configuration issues. It also can be around repetitive tasks due to lack of support, just because these devices are distributed geographically, and obviously, lack of operational overhead. You see, these four main challenges. Why are these challenges arising? The reason why these four challenges are arising at the end of the day is because these devices are present everywhere. They are present in terminals, in retail locations, airports, and even in train stations. These devices are in your school, workplaces, and in gas stations as well. Not only can you find them being used to manage industrial equipments, but they are also used as field computers in defense and in agriculture. In short, managing these devices are becoming more and more challenging because they are distributed across multiple verticals. But you see, the issues that I have mentioned earlier, they might change based on various factors. But there is one such issue that remains constant, and that issue is around achieving fail-safe deployments on your edge devices that are distributed across various locations. So in this slide, you will see the current state of deployment. And what I'm trying to represent over here is that the information from the industrial edge device is basically sent to a central edge platform through a local or central server. The edge platform, which could be an external software or a homegrown application, typically shares the deployment configuration to the server that distributes it across various edge devices that are located around the world. And then again, these edge devices, which are dispersed geographically, transmit raw data, including details about deployment state, configuration status, the time needed to complete the process, and device health across a single pane of glass. Your IT admin basically sees all of these information on one single console. So you might think that this deployment process is pretty perfect, but let me tell you that there are multiple problems associated with this deployment sequence, and they typically revolve around, inefficiency, geography, the presence of dysfunctional outlets, and, problems around maintaining personal records. And, it's not just me who is saying these things. There are some top analyst firms that are calling out these issues around deployments. And some of the most significant problems around edge devices that have emerged were a result of unsuccessful deployment, identity theft, and malfunction in retail outlets. Nevertheless, there are also complaints about issues with respect to productivity due to unavailability of deployment assistance, and some issues also had severe consequences. A study found out that a single day of downtime caused due to a clumsy deployment procedure basically costed an oil and gas company over $25 million. And some extremely technologically sophisticated hospitals and clinics have also acknowledged that 53% of the edge connected devices discovered in their facilities had known vulnerabilities, and nearly one third of them were at significant danger. So you can imagine the state we are in. And on top of these issues around the world, we can see industries that are embracing edge devices and are distributing them across geographically across various multiple locations. You see, spend on edge devices has increased and it will be increasing in the coming years as well. And the intelligence is moving from data centers to the periphery of the networks. Given this, there are a host of several diverse use cases, and in addressing these use cases, companies have seen an improvement in not only their revenue, but they have also observed that their deployment challenges have increased over time. And this is starting to show not only in one vertical, but in multiple verticals, like I have mentioned before. So you can imagine the level of issues that we are going to face at an extremely compounded rate in the coming years, which is why it is important for us to, implement DevOps in all of our edge devices when it comes to deployment. So we all know, right, that continuous integration, delivery, testing, and deployment in all of these things in secure framework have always been the primary objectives of DevOps and DevSecOps. But there are a few nuances when it comes to deploying applications at edge. So over here, what I want to highlight is that when it comes to managing edge devices, the organization should invest in both modernization strategy and towards application of DevOps principles. One should use continuous delivery as a backbone to move changes from code to test and then at the end to production. In the entire deployment processes, they should really focus on frequent testing, rapid releases, and security of the entire processes. And why I'm saying these things are important is because automated testing strategy is required to rapidly assess quality and risks involved in deployment and rollbacks. And same goes with release management, which helps you in safeguarding your applications from the bugs and errors, which goes unnoticed until the very end of the deployment processes. And in the end, obviously, the overarching security, it helps you in minimizing vulnerabilities in the applications by implementing and maintaining compliance into the delivery pipeline from day one by providing the ability to respond to changes rapidly. So you see, there is a need for providing a framework to securely deliver consistent and reliable software to the devices quickly, something which is pretty much unique to Edge. And Chef as a product is known for implementing the testing and security and as well as release principles, which are very essential in achieving fail-safe deployments. While Chaitra will talk about how Chef helps you in achieving fail-safe deployments at the edge, I would like to quickly touch down upon the benefits that you can derive from doing something like this. So when we talk about the benefits, right? Some of the major benefits that you can derive from implementing DevOps at edge are, it can help you lower the latency by moving your processing power closer to the network's edge. It can also help you in enhancing reliability and resiliency across deployment processes by providing you clear visibility and automated alerts. It helps you in, exercising regulatory compliance requirements in delivery pipelines from day one, and provides you with the ability to respond to changes rapidly, thereby enhancing your overall security. And in the end, it helps you lower your operational costs by automating the entire processes, thereby increasing your productivity and boosting your performances. So you see, these are the benefits that you can derive if you implement DevOps on all of your edge devices. I will let Chaitra cover a lot on how Chef Edge Management helps you in achieving fail-safe deployments in more details. Over to you, Chaitra.
So Adi walked us through your growing trends at the edge and challenges that come with growing devices and growing use cases at the edge, right? So basically, since these devices are out in the field, the connectivity is limited, or there could be unforeseen circumstances where a device is knocked down, or a warehouse worker just messed up with the machines, right? Um, and the device themselves could be resource constrained, right? They might have limited RAM, limited disk space, right? And it's not feasible for such devices to download frequently and download heavyweight software in such a scenario. So since the device capacity is limited and connectivity is a challenge, software distribution to these devices are very unreliable, right? It may work or it may fail. There's no way to know whether or not it was successful. And it gets even more challenging with scale, where an organization has a large number of diverse devices distributed globally. Say in case of a retail store, or manufacturing company, or hospitals, or anything, right? And these are the sectors, where they cannot be in a situation where they're unable to take a customer's order in a store, uh, or have their day-to-day business operations impacted in a factory, or their day-to-day operations impacted in a hospital. So it's very important that applications are deployed successfully and run uh, consistently without any issues. And another thing is that these devices may be tracking customer reward points, or they could have sensitive data like customer identification information, credit card details, etc. So maintaining security and data integrity in such devices becomes very important. And generally, these organizations have certain guidelines that they have to adhere to, like PCI compliance if they're managing credit card data, etc. Right? Um, and finally, if there's any failure or any issue that needs debugging, or needs they need to roll back something, then many times they have to send out technicians out in the ground, and sending somebody out the field every now and then to fix issues can be very costly to an organization. So the impact of a manual intervention feels even more magnified at the edge when compared to your traditional data center or cloud use case. So an automated approach could really help, could really help simplify things in this case. So typically, most organizations experience unreliable deployments at the edge, right? So let me walk you through a high-level workflow of what the situation in our customers look like prior to them adopting Chef, right? So the teams worked in silos. Developers used to develop applications and package them and deliver it to QA, right? And then the QA would test it on multiple different environments. So basically, they would have test environments that would mimic every possible production environment, right? So they would have to ensure that they test it in multiple different environments. And even after that, something wouldn't work, and then they would send it back to the developer for rebuilding the application, and then the QA would test it again. And finally, once everything is tested, they would hand it out to the ops team, which would take those applications through a CI/CD pipeline and again test it in multiple different environments, right? Uh, and even at this stage, there were possibilities where it didn't work, or it didn't work as expected, right? And then it would go back to the developers, and developers would rebuild, QA would retest, right? The cycle would go on. Once everything was completed, tested in different environments, once it goes to CI/CD pipeline, um, they would push out the software to production, hoping that it is, hoping that the deployment is successful, and hoping that the application would work as expected, right? But then many a times these deployments would fail, or they would get aborted in between due to disk issues, right? Generally, the workloads deployed were containerized and occupied significant space. So this would add to download failures, and sometimes network connectivity would also add to failures, right? As you can see here, every device in the every device in the remote location would be connected to the centralized server, and all of them would try downloading updates at once, right? So in a limited connectivity environment, and in an environment where devices have limited disk space, this is bound to cause failures. And this problem only gets magnified when there are, tens and thousands of devices to be managed in numerous locations across the world, right? Uh, so how do you achieve reliable and consistent deployments at scale with Chef Edge management, right? So with Chef Edge management, you can basically build, deploy, and run your applications as code. You can bundle the application with all dependencies to make it deployment ready, right? And since the dependencies are all bundled, it is immutable. It becomes an immutable artifact, and you get that guaranteed runtime when the application is deployed, right? And it will run consistently on any environment. And these artifacts are extremely lightweight, right? The lightweight artifacts and the peer distribution capabilities that the solution offers makes deployments easy and much more reliable than other ways of going about it. And then, you can perform easy rollbacks, perform flexible upgrades, etc. Right? And finally, you can configure your settings and manage security of your edge devices. So basically, you define in code what the app needs to be built, and you build it in a clean room environment. And then as you specify the dependencies that app needs to be built, you can also specify how it needs to be specified. Uh, and run, right? So all of this is bundled into a single artifact, and you deliver this artifact, you can deliver it to any environment, and you can be ensured that it can run consistently no matter what the environment is. So let me provide a basic high level overview of Chef's application deployment workflow, right? So once you have your application code ready, you define a plan file to specify everything that your application would need, right? You would declare your dependencies and your configurations, etc., and then build the artifact in the studio, right? So what comes out of the studio? Studio is the clean room environment where you basically build your application artifact. And what comes out of the studio is the artifact that is pushed to the builder or depot, right? And the builder or depot is where you basically upload your application artifacts and maintain them, right? And then you have an agent called supervisor installed on your production devices, right? And these supervisors pull in the updates from the builder or depot. And the builder or depot basically delivers the artifact to the supervisor, right? So once the artifact is delivered to the supervisor on the device, the supervisor basically, runs and configures the application, and then it is also responsible for monitoring, so on and so forth, right? So supervisor is basically the agent which is responsible for orchestrating application upgrades, etc. And earlier I was talking about peer distribution capabilities, right? So supervisor it is from this point where supervisor can connect to other supervisors and other devices, form a network to perform peer distribution, etc. I will be talking about how the peer distribution or how the application deployment workflow itself would look like in a real use case in the upcoming slides. So yeah, talking about how can you achieve fail-safe deployments with Chef, right? Just imagine, like, you have a centralized location from where the management happens, and you have the supervisors installed on all of your remote edge devices, right? Um, so similar to what we saw earlier, right? The team defines the plan file, specifies the application dependencies and configurations, and it goes through a CI/CD pipeline, and the artifact is uploaded to the builder or depot, right? And then and now you have all your remote devices in your remote location, right? Instead of having all your devices connected to the centralized depot, you can just have one device from the remote location connect to the centralized depot, and then you have a local depot installed on that device, right, which pulls updates from the centralized depot. And then as you can see, all the remote devices have supervisors installed, and these supervisors form a network which we call as a ring. So the one device that is connected to the centralized depot basically distributes all the updates and configurations to other devices in the ring, right? Um, and then it is this device that also can share can be connected to the visibility layer, and that's where you can visualize the state of your fleet, right? And as you can see, the artifacts, the application artifacts installed on the device are extremely lightweight and occupy very little disk space. And as opposed to the earlier paradigm, instead of having all your devices connected, you have a single device connected to the centralized location, which basically avoids being in a situation where you have all the device trying to pull in updates. Um, and they could like cause failures and stuff, so that doesn't happen. And then also the lesser the number of devices connected, right, you also reduce the threat surface area. So even from a compliance or security point of view, this paradigm is a really secure approach to go about your edge deployments. And imagine this happening at scale, where you have, remote locations and, tens and thousands of devices across the world that need software updates and configurations. And also the peer distribution ensures that you have fewer devices connected, right? And uh, the artifacts reduce disk space, etc. So just to recap the two scenarios, right? On one side, you have every device connected to the centralized location, and all devices in a location try downloading updates, and you have deployment failures, etc. Right? And the application artifacts are also heavyweight, and hence downloads are prone to failure due to limited bandwidth, etc. On the other side, you have just one device from each location connected, right? And the supervisor pulls updates and distributes to the other devices in the ring. And the artifacts deployed, are extremely lightweight, occupy very little disk space, which reduces download failures, and makes and is a much efficient way of deploying software to the edge. So Chef can transform your software distribution process at the edge, right? So you can achieve 99.999% successful deployments. And since the deployments are always successful, the teams don't have to spend time validating and fixing issues. So that actually improves team productivity. Since the artifacts created with Chef have self-contained dependencies and are immutable, right? Once they are tested, they can run consistently in any of your production environments. So your developers and QA, they don't have to spend hours and hours of time rebuilding and testing applications to make them work. So I've reached the end of the webinar here. Um, and do you have any questions that I can help with?
Thank you, Adi and Chaitra, for your presentation. There's a couple of questions that came in, so we're going to go ahead and jump right into those questions. The first question is, are deployment rollbacks supported?
Yes, of course they are supported. So you can also, configure your plan file in a way that allows you to automatically roll back whenever a problematic code change is deployed. Or, if you don't want to do it automatic, the depot always has the previous stable version of your application saved. So you can also do it at your will with by running a command or something. But yeah, you can do that in like seconds or less than a minute, actually.
Excellent, thank you. Another question here, what are the supported devices and device types?
So, any device that has a Windows or Linux operating system is supported. Even if the device has limited RAM or disk space, Chef can support them. So, it could be your point of sale device, it could be your single board computer, or it could be any of your field computers or kiosks or anything, right? Chef can support them.
Excellent. One last question I'm seeing here, is it possible to perform controlled upgrades with this solution?
Okay. So controlled upgrades in the sense, I assume what you're asking is, can we uh, perform upgrades when, the device allows you to? If that's the case, yes, you can definitely do that, right? So when you define your plan file to, bundle your application stuff, you specify dependencies, right? But then you also have the ability to add pre-check conditions to be checked before you perform the upgrade. For example, let's say in a store like scenario where a customer order is being processed, right? And you don't want to upgrade when that is happening. So you can add that as a precondition, asking to pause an upgrade if an order is being processed, or let's say if the device is getting restarted, or something like that. So basically, when you add that pre-check condition, it basically checks for the task to be completed, and only then the upgradation process will continue. So yeah, and Chef is known for its flexibility and ability to customize operations the way you want to by with the power of code, and it's still and in spite of being able to customize and doing everything, you can still resume your business operations without any hassle, right? You can just easily do that.
Excellent. Thank you for answering all of those questions. That is all the questions we have for today. Thank you all for joining us on today's webinar, and we hope you enjoy the rest of your day.